Okay, we are recording. This is building query / sprint D demo for February 28th. We're going to demo the work done over the last 2 weeks, sprint D, and also kind of preview the work or what the tech will look like for our, some of the coming features in 0.4.0. I keep talking about it like that, but it might be 3.6, whatever. And what the tech could and should look like for our School of Data workshop next Saturday. Cool. Bear with us a little bit in the room. We're going to be passing both the volume and the microphone to each computer, so don't worry about it, but it might just take us a second to figure this out. Did we have an agenda?
So Kasey, do you want this? So we'll go Kasey, and then Dustin, do you have anything?
I don't think I do. I'm still doing a lot of the back-end refactoring around DS Cache.
Okay, cool. Then I will officially pass the conch to Kasey, if that's okay. I'm going to mute and turn off my volume.
Unmute, and I'm going to turn up my volume. Okay, cool. Can you hear me now?
Yeah.
Thank you. All right, so I'm going to share my screen, and I'm going to show you a little bit about what I have been working on today, or this past 2 weeks. So I have a build of Qri. This is a release candidate. This is actual production version of it. So, well, let's see. Let's dive in. We're going to on today's lesson, we're going to pull in a data set, and then we are going to edit it within the app without having to link it to the file system. So this makes like the responses a lot quicker because we don't have to talk to the file system to find out if anything changed, because we know it changed because it's in the app. And we are, besides being able to edit meta, readme, and structure, you can now drag a body file over the workbench of the body that you're actually trying to change, and it will, Qri will then know to pull any new changes from the next commit to that data set. Okay, so let's find, I was looking for data set to work here. So I'm going to use my LOL stats dataset, which is the professional League of Legends, all professional League of Legends games, the stats for each player from the 2017 summer and spring season. So first, I'm going to create the dataset by dragging the body of the dataset over the collection view. So if you drag it over the collection view, you create a new dataset. If you drag it while you're actually looking at a dataset, then you get a new version of the body. So it's like a distinction there. So dragged it in, we have the body, we automatically come up with the structure, and it parses the schema and lets you know some stuff about it. So now I want to make a couple changes. First, and this isn't a new feature, I'm just going to rename it, I'll call it LOL match stats 2017. I'm going to make it LOL pro match stats. And then I'm going to head over to the status pane here. Sorry?
Did it go? Oh, sorry. I thought the name wouldn't change until you did.
Yeah, I think it's also on unfocus.
Cool.
So here, even though we don't have a README or a meta yet, we still have the option now to edit it. So I'm going to add a title. League of Legends Pro Match Stats 2017 Spring. Can't type when everyone's watching you. Summer seasons. Okay, cool. Someone is texting me. Stop. Get out of here. Okay, so now when I have made that change, the query is letting you know, hey, there's a change here, and you can have the option of committing. So I'm just going to say added title and commit. So once the commit goes through, it will flip me over to history, and I can take a look at the changes. Okay, cool. So, yeah. So if you look at the previous data set here, it let us know that the first things that, the things that were created were the body and the structure. And if I look at the second commit here, once it actually does the fetching, it lets you know that that the meta is the thing that changed here. You can see this. Okay, so why don't we just do the same thing? Oh, and if you look here, look, it's changed. I'm gonna add README. I don't remember all the details of this because I did this like a year ago, but pulled from data scientists, or from like League Data Scientists website, and convert, this is what I'm remembering that I did, converted to CSV from query. Okay. Okay, so now let's say let's say I'm gonna just add some descriptions to a schema here. What's an easy thing? ID of the player, or player ID. See, the orange indicates that it was modified, that it is not a new component, but instead is a modified component. Let's say I'm like, I hate that description. I hate every description that I put in this list. I want to get rid of it. You can right-click and discard the changes of that component, and it'll go back to what it was at the previous commit. So it won't remove the component. It'll just bring you back to head. It'll bring you back to what the last thing that was committed. So I'm just gonna commit this to and yeah, so now let's say that I actually have a new version of this data set or a new version of the data set body, and I want to change it. So while in-app body editing is something that is on our roadmap for now, while we perfect our ideas behind it, you have the ability to drag in another CSV file to replace the body. So I'm actually gonna pick a data set that is totally different schema, and it will not break, but you will see the schema, you'll see what happens. So instead of pulling it over the collections pane, now I'm dropping the body onto the previous body. It lets you know, hey, this is a file. Let's say I'm like, that's not the right file. You can remove it and it'll remove the reference. But otherwise, I'm just going to say changed body. I'm going to commit. And then now you see, hey, we still have the same structure, so it didn't change the structure. You would have to manually do that. But it's not breaking if your data set changes schemas. So yeah, that's my demo. Any questions?
That's fantastic. I'm afraid that
Everyone's muted.
The next person.
I'm afraid to ask questions because we're going to cut so much feedback in this room. I thought that was awesome.
Okay, cool.
Yeah, and then you can't respond, Kasey, because I have the talking stick. But here, I'll give it back.
Okay. Does anyone not in this room have questions?
Is the performance problem there when you were like saving after the meta change? Do you know if that's like, is that something you normally see? Is that something because it's like weird over the API, or was that just like computer being slow?
It's something that I have only noticed from, I've only noticed the difference. Hey, should we try editing a checked out data set and see if the performance is different? Because it is markedly different in this last, I guess to say, I've only just noticed that it is slow in this last feature. And I can't recall whether or not it has ever been that slow, although because I haven't recalled it, it makes me think that it hasn't been,
That's okay. It's more a question of like, are you seeing it all the time?
I'm seeing it all the time.
Okay,
Actually, I think it might have to do with the body size. Like, I wonder if we use the small body and then change something.
Right. Well, I mean, I wonder, like, if it's, just changing the meta, hopefully there's something we can, like, circumvent all the body stuff and just, like not even do stats and all that.
Totally, since we specifically know that unless body or schema are changing, they're not affecting each other. And even then, no, structure would potentially change. No.
Not if you're changing meta.
Yeah. Okay.
Right.
No,
Seems
not
like,
if you're changing meta. If you're changing meta, nothing else should change. So yeah, maybe there's ways that we can optimize it.
okay. I mean, it's something we'll keep an eye on.
Cool. I'm passing the stick. What?
Brennan seems to have something he wants to say.
Okay, I'm passing the stick.
I heard none of that.
Oh, well now my mic is activated. So I have the power. Let us share a screen. Okay, are you seeing a infographic-y looking thing about bicycle counts? Bikes! Okay, so, did you say bicycle like Queen? Okay. Yeah, so I'll demo, we did, this is a little data story that we knocked out last week on bridge bicycle counts. So the background on this is that I've been casually diffing the catalog JSON feed from New York City Open Data Portal, just because every day, if you diff it with the previous day or the previous time you diffed it, it'll tell you all the modified data sets and when they were updated, basically how many days since they were updated, and it'll also say new ones. And this one just came across the radar as one that I hadn't actually seen before. And then I asked my friend Noel on Twitter, has anyone done anything with this data set? And he was like, no, it's pretty new. It's only been around since December. But the Department of Transportation for New York City has put out very granular 15-minute frequency counts at 14 locations around the city, 3 of which are these bridges. So we just kind of narrowed down the data set. The original data set on Open Data had 7 million rows in it, 15-minute frequency. So for each location, it includes individual directional counts and then a total count for both directions. So what you're looking at here is three of the locations, bidirectional counts. So we're not worried about direction in one way or the other, but total counts. And then the year 2019. So the data goes back a few years past. So we just wanted like a nice time frame to visualize. We said, what can we look like here if we compare these 3 bridges? And then what we see in the data is some, the seasonality that we would expect is more traffic during summer times. And, when it gets cold, there's less. But what was really interesting is that if you correlate it to weather, there's like 2 vertical gray bars on here. And one was like a spike during the winter months where it was unseasonably warm. You see that spike across all 3 bridges, which is fascinating. And then the same thing in May, there was like a really cold Monday, Tuesday in May, and bicycle traffic dipped. So there's probably lots more of those throughout the data, but those are ones that really stuck out. And if you just look up the data, look up the weather data online, you can find that the temperature spiked or dipped, and it's kind of fascinating. The other thing that's interesting about this is, just putting some numbers behind it, you can see that 573,000 bikes traveled across the Brooklyn Bridge, and the Williamsburg Bridge carries over 3 times that much with 1.7 million trips. Those are, we probably expected the Brooklyn Bridge had lower, but now we know exactly, some order of magnitude how much. So that's interesting. And then probably the most interesting and helpful part of this is that there's a spike here in the Williamsburg Bridge in December, and my initial assumption was that it is a data error, but we've now confirmed that by getting in touch with DOT. So this is cool because it's kind of talking about the feedback loop of that's missing with open data. Is that you can make these kinds of visuals and put them back out into the world. You can actually start a conversation, which is wonderful. So this made it back to the data publishers and caught their attention, and they did we contacted them and they said confirmed that there was a a problem at the end of December that they were actually logging hourly data, or I guess hourly counts alongside the 15-minute counts or something like that. So anyway, they're addressing it and they'll republish it. So I think that's going to be a nice little outcome of this, among many others. But yeah, I think this was a fun one to do, and I think we'll get some more eyeballs on this data set and stuff you can do with byte counts. So,
question: by republishing it, does that mean that they're going to publish the exact same like time span, like the same data set, just with a correction applied?
I believe so. I don't think they're. I mean, I think on the Open Data Portal they can actually reference. I don't know if they can actually.
Well, I mean, either way, that's like a really good thing that Qri is designed for. That's really cool.
Yeah, for sure. So I mean, like the data set used in this visual just for 2019 data for these 3 bridges is in Qri, and you can link to it from the blog post. But yeah, it'll be cool to, you know, when they put out a new version, we can just clip out 2019 again and just compare it and be like, hey, what's actually different? Is it just those days, or was there other stuff that they modified? I think that'll be a good use case to follow up on.
You can diff it to make sure that everything else is the same.
Yes, perfect. Yeah, make sure they didn't accidentally update something else.
Cool.
Yeah. All right, I will now pass the baton to Brendan.
Okay, cool. Can everyone hear me okay?
Yes.
Okay. Yeah, so I don't have a ton to demo. I think Kasey and Chris's demos were far more interesting than what I'm going to show today. Really excited to have in-app editing as the thing, and very excited to see us actually sort of making some real inroads on data publication, not just tools production. But yeah, I just wanted to sort of like loop in on a conversation that's been happening and sort of as like a nice sort of open source story that I think sort of rounds out the day quite well. So let me share my screen. And not really going to be a technical demo today, more of a storytelling demo. We had a user come in and ask like the question that we get a lot, which is just like, how long does it take to put stuff into Qri? Like how big is big when we're talking Qri, and how small is small? And this user, big shout out to Sam Gammon, who's saying F it, ship it, which is a phenomenal status for GitHub. He sort of reached out and said, hey, like I just want to know how big is big, and then we started a conversation, and you can read this at this URL. But then Sam went above and beyond. He told us that it was deeply confusing as a user, which is really helpful, and gave us concrete things to work on. And then he went and like performed benchmarks using Unix tools to talk about how much data was a lot of data for him, and came up with like, he ran this, he sort of showed his work, really showed how much, how he went about sort of producing the results that he got, gave us a table of results, and then gave us some charts of those results, which show us exactly how well Qri is performing right now. And then he went like the millionth mile and created a data set of the results and published it to Qri. And so I thought this was just like the greatest thing in the world. And not only did he publish it, he sort of like gave us a really nice indication of his methodology, right? Like this README, I think, is like why we built the README component in the first place. Like I literally used this to say, I think and I sort of mentioned in this comment that I was in a comment in the issue as we were describing it, that like, I think that this sort of set of data that he's producing, just to give you the data that he made, he's sort of showing a data set with 10K rows that is 11 megabytes, and running the init command on his machine was taking 0.97 seconds of user time, almost 900ths of a second of system time, 138% of his CPU, which is kind of normal, and then 0.7 seconds of real sort of like total time is how you sort of read this. And he gave a nice link on how you would read that and how you would pull that apart from the man docs, which are the manual for Unix. And then sort of we get into like some of the stats, and the things like stats that we have to work on are like, it took to add a data set that was 1 million rows, that is roughly 1.1 gigs in size, took 212 seconds to save. And so for me, a project that I'm really inspired by, that I think is delightful, that is also incredibly open source, is Deno, which is an anagram of Node. It's from the author of Node, and they have a page of benchmarks, which shows how well their app is performing from each commit to master. And I think that this is just like a wonderful thing. And so what I wanted to sort of show today was, we are in doing some like proper dog fooding. I think I'm basically taking the process that a user had submitted, and I'm trying to write a CI tool that creates a data set that runs a version of these benchmarks that Sam created every time we commit to master. So we can get close, eventually get to something like this, where we can see for every commit, how is performance working from time to time. And so that's what I worked on last night and got it to a point where we have a couple new tricks that I'd like to share. The first one we needed, that Deno has out of the box, that was a really nice one, is this is sort of like one line install. You can just do this. Curl fssl Deno install at sh, pipe it to shell. It's always a little scary, right? You know, we should put the warning on the tin that piping to shell is this is a great way to like do bad things to your computer. And so if you should always sort of check these scripts before you run them. And this gives you a nice preview of it. But we now have something very similar. And for us, it looks like, let's make sure we actually have it up. No, we don't. Oh, we're in the wrong thing. I'm confused. Hold on 1 second. This will work for us now. So you can now run this and it will install a query. And what that did, this is the query CLI, which is sort of the only feature that I can sort of speak to today. The other thing we did is we built this like shell script that, thanks to Sam's comments, was really easy to sort of construct. It was able to like understand his process sort of exactly point for point and build this script to sort of reconstruct the data set from the README and the issue that he posted. And so now we have a script that creates a CSV file of performance benchmarks, and we have a mechanism for installing query, and all we need to do is wire it up into a thing that in this case, I'm gonna run in Circle CI. And what it'll do is every time we push to master, we want to finish all of our tests pass, and then we want to download query the binary, and it up with the local user profile, run the performance benchmark script, create this performance CSV file, version that CSV file, publish that back to the cloud, and then close out the image. And so this is, I'm not gonna run it because it obviously takes a long time to run, but this is an example of that. So this is like a local sort of dev version of our Circle CI continuous integration. And this is spinning up an environment, checking out code, just doing a little bit of listing and then installing curl. And then this is that script, which is just installing query, setting everything up. And so we now have, and I'm using a special config variable that allows me to plumb configuration. And so on the Circle CI side, we've stored our user profile data in a secret that is accessible so that when we download it and run setup, we're not creating a new profile from scratch, we're using a profile that already exists. And then we're running the performance benchmarks. Once we have an output, we save that output and we version a data set and we publish it. And so to see what that looks like, this is what it looks like. And so we have a basic, which looks really close. I now have to obviously go through and write the README for this and very much cite Sam's work as the precedent for this. But this should be in sort of next week. We should have this running every time we push to master, and we'll actually be able to see how long it takes to add a 960 megabyte file to remove all command in terms of real world user seconds. And then we can build visualizations that graph that, and then we have the sort of like wonderful holy grail of a versioned, ever evolving data set showing which commit over time. So
we should send him a sticker.
We should totally send him a sticker. Sam, if you want a sticker, we're gonna send you a sticker. But yeah, that's kind of all I wanted to demo today. I thought it was like a nice story of how I think open source working the right way is a great way to sort of cite each other's work and build off each other. And in a little bit of dog fooding thrown in while we're at it. Any questions?
It's exciting.
Awesome. I think, Rico, do you want to round out the demo, or is that, or are we? Yeah, I guess that's it for this week. Thank you so much, everybody, for joining. We're very much looking forward to a release showing a lot of the work that Kasey demoed sometime next week. And in the meantime, see you on the internet.
Any open forum for questions, issues?
Oh yeah, I guess any open forum for questions or issues right now. Anybody? No.
What was the question? Any what?
I think we were going to do a question and answer period, but we didn't really plan for one.
Gotcha.
But yeah, amazing. Okay. Well, thank you so much, everybody, and we'll see you next time.